In this video, I will show you how to simplify imaginary numbers. So if you look at this, this is the front side of the note and this is the back side. So here in front side, I will go over this questions quickly. If you missed it, just pause it and run back to it because you have plenty of time here. So what is imaginary number? This is simply square root of -1, which we call it I. Normally, we cannot have negative number inside the square root. That's why we call it imaginary number. So here's an example. If you look at it, here we have square root of -4. And this can be broken down into square root of 4 times square root of -1. Because -1 times 4 gives you -4. Again, square root of 4 is equal to +2. And if you look at it here, square root of -1 is equal to I. So 2 times I is equal to 2I. And this is how we do it. And here it's the same. We can break it down into square root of 5 times square root of -1. And again here, square root of 5, this we cannot break it down. We cannot simplify further. So this is just square root of 5, but square root of -1 can be rewritten as I. So this is square root of 5 times I. And here we go. This one is more fun. Here, only difference is 12 can be broken down into 4 and 3. Because 4 times 3 is equal to 12. If you break it down into 6 and 2, that's fine as well. Because at the end, you will get same answer. So here, those are my prime numbers. So in this one can be rewritten as 2 times 2 times 3 and square root of -1. And again, we have one pair here, so they can go outside and one cancel out. So 2 square root of 3 times, again, this one is gonna be I. So this is the basic concept of simplifying imaginary number. And here are check for understandings. Well, due to time, I will go over some questions, only maybe 2. So here, -80. This one, oops, let's not do this. This one can be broken down into square root of 80 times square root of -1. This should be simple now. And 80 can be you can break it down into 10 and 8. And again, this one can be break it down into 5 and 2. 8 can be break it down into 4 and 2. So here, this is interesting here. If you look at it, we have prime number here, 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 and here. So if you rewrite it, that's gonna be 5 times 2 times 2 times 2 times 2. And again, if you are not familiar with simplifying radical, go to YouTube and type simplifying radicals. There's a lot of videos that can be helpful and can explain much better than me. So here, which one can we take out? This and this. So this, you can take it outside. Again, one of them will disappear. So we have 2 times 2 because we took out this one and this one. And inside, we still have 5 left over, which is 2 times 2, 4, square root of 5. And again, here, let's not forget about it, which is I. That was easy. And maybe, which one looks easy or hard? I mean, all the questions are very straightforward, so here, let's do this. 162 times square root of negative 1. Now, this one can be broken down into, here. So it's going to be about 81 and 2, right? And 81 is 9 and 9, if I'm right, because 9 times 9 is 81. And here we have a dilemma. We can break down 9 into 3 and 3, but since we have pairs already, we can just skip that part. So we can just write it here, 9 times 2, and times square root of negative 1. Let's not worry about this because I'm not going to go over this. And here again, we have a pair. This, we're going to take it outside. 1 will disappear. So we have 9 square root 2. And here, square root of negative 1 is going to be equal to I. And again, I went over a bit fast, but if you have time, just go back to the video and look at it. That should be solid. And here, let's go over power of I. That actually should be the main lesson. Here, I is equal to, again, square root of negative 1, which is just I. Because mathematicians are lazy, we do not want to write negative square root of negative 1 every single time. I squared is square root of negative 1 squared, which is going to be square root of negative 1 times square root of negative 1, which will give you negative 1. Now, I3 is going to be more interesting because I cube is I squared times I. Because if you look at it right now, I squared times I, now we have 3 i's, right? And again, if you look at it, I squared here, this one is equal to negative 1 here. So instead of I squared, I'm going to put negative 1, and for the I will just put I, which is going to be just negative I. Let's look at I to the 4th power. I to the 4th power, this one is same as I squared times I squared. And again, I squared is negative 1, so it's just negative 1 times negative 1, which is positive 1. Now this, for multiples, or should I say, powers, they are very important because no matter what type of power you have here, your answer is going to be one of these 4. An easiest way of solving this is to subtract multiples of 4. Here, for example, we have I to the 17th power. Now, if you look at it here, I to the 4th power is equal to 1. So we're going to subtract multiples of 4. And I to the 17, to me, it looks like just I to the 16th power times I will give I to the 17th. Because 16 plus 1 is equal to 17. And again, I to the 16th power, this one is like 1 times 1 times 1 times 1. So nothing changes. So this one is equal to just 1. So this answer is going to be just I. Because 1 times I is equal to I here. Here, let me give you a better example here. I to the 22nd power. Again, this one can be broken down into I to the 20th power because that's the multiples of 4 times I squared. Again, I to the 20th power, that's multiples of 4, which will become just 1. I squared is, according to this one, it's gonna be -1. So it's 1 times -1, which will just give you -1. Here, 2 more questions. Now this is easy. 2i squared times 3i to the second power. Here, if you look at it, second power is outside of parentheses. And if you know, there's a hidden exponent here, which is 1. And what you're going to do is you will just distribute it here. Okay. So let's do this. This one, we just bring it down. 2i squared times, but this, we're going to distribute, which will get 3 squared times I squared. And again, this one is going to be what? 2i squared, and 3 squared is equal to 9i squared, because we have I squared here. And again, if you know I squared is equal to -1. Just don't forget about this. So this one is same as 2 times -1, which is -2 times 9 times -1 is -9. Again, -2 times -9 is gonna be positive 18. Easy peasy. Here, this one is the last concept of this note. If you break it down, again, there's a some mistake that you can make. You cannot do it like this. Again, this one, this is not true. Because in imaginary number, always you have to remember you have to break it down into 12 times -1, square root 5 times -1. These two should go together, okay? Which is going to be I squared. And what you have to do is you just have to break this down. Here, square root of 12 times square root of 5. If you multiply these two numbers, that's going to be square root of 60 times, and square root of -1 times square root of -1 is going to be just -1. Okay? And let's see if we can break it down further. This one, again, we can break it down into those, let's see, 12 and 5, because that's what we multiplied. This one, 4 and 3, 2 and 2. Yep, we got the couple here. We have a pair, and we have a prime numbers here. So again, this one is same as square root of 2 times 2 times 5. Oops, I forgot about 3 here. And -1 at the end. And again, if you take it away, that's going to be 2 square root of 5 times 3 times -1. And if you simplify it further, here, -1 times 2 is going to be -2. And here, 5 times 3 is going to be 15. And that's it. Here, if I have more time, I will try to make more video, but I think